two separate spots.
To see if they have association.
Correct, to see if there's an association. Okay, so in our example here, it says, what kinds of people do not use seatbelts? That's what we're trying to prove. A random sample of 459 people asked if they wear a seatbelt while driving and how many cigarettes they smoke per day. The study wanted to test the claim that the amount of smoking is independent of the use of a seatbelt. That is the theory that is based on the idea that people who smoke more are less concerned about their health and safety, therefore less inclined to wear a seatbelt. Is this theory supported by the data? Use a 0.05 significance level. Okay. Because this mentioned the claim and asking if these two categorical variables are independent of each other, that's how I know I'm using chi-squared tests for association and independence. Okay, so starting with my communicate, I always put what two things in communicate? Hypotheses and the table. What table? Expected counts. So my hypotheses, my null hypothesis, notice in the question it already told me what my claim is. Okay, they're trying to see if they are independent. So my null hypothesis is that the amount of cigarettes a person smokes is independent of whether they wear a seatbelt. Okay, and what does independent mean? They're not related. Okay, so our initial claim is to say that if you smoke cigarettes, that has nothing to do with whether or not you're going to wear a seatbelt. Okay. Our alternative is going to be the same exact sentence, but instead of saying is independent, we're going to say is not independent. Just make sure on the homework in the FRQ you write out the whole sentence. Okay, then we do our expected counts table. And remember, we do not need to calculate this by hand. If we don't want to, we can go straight to Desmos and we would click on inference and then what? Good. Chi-squared test for independence. Type in all your observed data, and then on the first drop down, after we hit create test, we'll have all our expected counts inside the parentheses. Okay, so let me just set up my table, and then I will show you where to find it. So again, I'm going to go to add an inference. I'm going to look at chi-squared tests for independence. And then on my notes, I'm going to go up here where I have my observed values, and I'm going to type these numbers in. Okay, so 175, 140, 20, 18, 42, 43, 6, and 15. Once I type in all my data for my observed counts, I hit create tests. I go to the drop down that says observed, And then all the numbers in the parentheses are my expected count. So I'm going to write that on my table. Okay, and if there's decimals, make sure you include those decimals.
Looking at the significance test, will it always be, I know we're not there yet, but will it always be 0.05 for like the chi-squared? Because it doesn't look like there's a place to enter in like the significance level.
I see. Okay. No, because the only reason we use alpha is just to draw our conclusion. So it's not going to change our data no matter what alpha is. So if the problem is significance level of 1%, there's no need to put it into the data because it's not going to affect. Yeah. Mm-hmm. It's not like confidence interval where you need that. Mm-hmm. Okay, so that's all my data. Again, it was all the numbers that were in parentheses on that part. So that is my communicate. Okay, then I'm going to go to because I'm running out of space. Okay, conditions. Okay, so remember my conditions, I'm checking the same three. So first I'm going to start with random. And what does it say in the problem about random? Good, a random sample. So that's good enough to prove that condition. Then I go on to independence, and I'm using which condition? 10% condition. And then since I don't necessarily have a sample size, I use the table total, which they give us in the problem, and that's what number? 459 is less than or equal to 10%. And what's my population here? I mean, that would work, all people that drive, because it didn't really give us an age. But technically, should teenagers be smoking? No, so would it be all people that drive or just adults? And they're also not saying driving wearing a seatbelt. They're just saying wearing a seatbelt in general. So let's just say all adults. Okay, you would not get marked wrong if you were more specific. Okay, unless you said all people, right? Because then you're bringing in children into this, and children don't drive or smoke. So then that's not included in the population. Shouldn't, right? Shouldn't. Okay, then we do our large counts. And remember, for large counts, we look up at our expected count, and we need to make sure that they are all greater than 5. Are they?
Yes.
Okay, so we write all expected counts are greater than 5. Okay. And then I move on to calculate. Remember, in calculate, before I write any of my answers, I need to write the name of my inference. And what's the name of my inference? Good. Test for, and we always write both names because they're associated with each other. So association / independence. Okay, so that's the name of the inference. And then since we already typed in all our data, if I just hit the drop down for significance test, then I have all my answers there. So I have chi-squared is equal to 6.297. I have degrees of freedom equal to 3, and my p-value equal to 0.098, and then my alpha from the problem, which is 0.05. Okay, and then what's my last C? My conclusion. Okay, and remember, for all the chi-squared tests, we were always comparing our p-value to alpha. So I say since our p-value equal to 0.098 is larger or smaller? Larger is larger than alpha equal to 0.05. We fail to reject the null hypothesis, which means we have or do not have. We do not have convincing evidence that what?
The amount of cigarette smoked is not independent on whether they wear seatbelts.
Good. So the evidence that